Hey guys, Mr. Milton here. Today we're looking at quadratic formula notes. At the end of this video, you should be able to solve quadratics using the quadratic formula. Okay, so far we've learned how to solve quadratic in 4 different ways. By graphing, by using square roots, graphing, square roots, completing the square, and factoring. Okay, what if none of these ways works? Okay, other method we know, or we'll find out, we'll learn how to solve quadratics using is the quadratic formula, and it works for any quadratic. Okay, however, it takes a long time, and there are many places where you can make a mistake. So, as we work through these examples, pay close attention to some of the tips that I give, and be careful with your basic math. Okay, so our quadratic formula is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and I say opposite b, one of the first places that we can make a mistake because a lot of people see negative and always do negative. Okay, it's opposite. Whatever the b value is, you do the opposite of it. Okay, so let's go from there. All right. Notice that the fraction goes under the whole numerator. The entire thing is not just the radical. It goes over the entire thing. So the sign between the first term, opposite b, and the radical is plus or minus. Do not forget the sign. Remember that separates that we have to do 2 things. We have to add and subtract. Just a way to write that succinctly, I guess. So in our first problem, we have 3x squared plus 9x plus 6 equals 0. Because of the use of a, b, and c so much, I would recommend that you go back to identifying your a value, your b value, your c value before you start this problem. Okay, remember we can only do that once the equation equals 0. So, equation equals 0, we've identified everything, now we plug it into our quadratic formula. X equals opposite b, so negative 9, plus or minus the square root of b squared minus 4 times a times c. Okay, all over everything over 2a. In this case, a is 3. So as you plug those values in, make sure that you're thinking of those numbers and where they go and not accidentally plugging in variables. Okay, so as we simplify this, my first step is just to go through, multiply the numbers that they give you and write those out. I would recommend that you do this for a c as a number by itself. Don't include the minus sign, okay? And you want to take the steps at a time. Like I said, it does take a significant amount of time to do these problems, but if you're going to take that time, it's better to do it right. So I have opposite b's, negative 9, plus or minus the square root of, this first term should always be positive. 81 minus 4 times 3 is 12, times 9, or sorry, times 6. See, I caught myself already in a mistake. A lot of spaces for mistakes. I wrote 9 twice because I was off-centered. Our c value is 6. And if you're yelling at me, I can't hear you. This is a recording. All right. So 4 times 3 is 12, times 6 is 72. Okay, 2 times 3 is 6. All right, so now we've got that done. We're going to simplify inside this radical, and we have x equals negative 9 plus or minus the square root of 9 over 6. Okay, simplifying square root of 9, negative 9 plus or minus 3 over 6. So I'm going to do that, both of those. Negative 9 plus 3 over 6 and negative 9 minus 3 over 6. Simplifying both of those, this gives me negative 6 over 6. which is negative 1. This gives me negative 12 over 6, which gives me negative 2. And so my solutions are x equals negative 1 and negative 2. Problem number 2. We have 2x squared plus 7 equals 15x. Okay, before we start, remember that we can't identify a, b, and c until our quadratic is set to 0. So I need to subtract 15x from both sides. Okay, remember there are no like terms with 15x on this side. So I have 2x squared minus 15x plus 7 equals 0. Now that I'm there, I'm going to identify a, b, and c. So a is 2, b is negative 15, and c is 7. Okay, a lot of people make the mistake at the beginning of this problem say, oh, b is 15, because they saw 15 there. Okay, we don't set those until it's equal to 0, and that's why. Okay, so now we plug in our values. X equals opposite b. Since b is negative 15, the opposite is positive 15, plus or minus the square root of b squared minus 4 times a times c, all over 2a. Okay, all those values should be correct. Okay, good, good, good. Again, I want to make sure that I do this by itself. Okay, so as I do that, x equals 15 plus or minus the square root of 225 minus 56 over 4. Okay, 225 minus 56 gives me 169. Square root of 169 over 4. And so as I simplify that, x equals 15 plus or minus 13 over 4. So now I split it just like we did last time. It can be 15 plus 13 over 4, or 15 minus 13 over 4, right? That's what that plus or minus did. So plus 13 gives me 28 over 4, 7. That's 2 over 4, that's 1/2. So my two solutions, 7 and 1/2. All right, and that's solving it using quadratic formula. Let's look at some applications with this. All right, a child throws a ball upward with an initial velocity of 15 feet per second from a height of 2 feet. Using a vertical motion formula, h equals negative 16t squared plus bt plus c, where h is the height of the ball and v is the initial velocity in feet per second, c is the starting height, and t is the time in seconds. Okay, so here it goes. It says, first, plug in what we know. So what do we know? From the situation, we know the velocity. Okay, sounds like a mouthful. Sounds like, what is this? Okay, but they just gave us a bunch of information and an equation to plug it into. Okay, so we know the velocity, we know the starting height. Our new formula should be h equals negative 16t squared, because we don't know t, plus our velocity was 15 feet per second, so 15t, plus c stands for our starting height, and that was 2. Okay, so we have a formula where the unknowns are the height and the time. Okay, those are our variables. Okay, now if no one catches the ball, how long will the ball be in the air? Round your answer to the nearest 100. That's 2 decimal places. Okay, we are looking for a time. So we need to solve for t. Okay, if no one catches the ball, then eventually the ball will hit the ground, which has a height of 0. Okay, so now we understand what our height is. We don't even have 2 variables. We have just 1. Our formula should be 0 equals negative 16t squared plus 15t plus 2. And since the quadratic is equal to 0, we know we're solving for it. And therefore, we can use the quadratic formula to find the time the ball was in the air. With our formula there, we're going to identify A, which is negative 16, B, which is 15, and C, which is 2. And plug it into our quadratic formula. X equals opposite B, negative 15, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Okay, so did that. I'm going to make sure that as I go through, being careful with my terms, that I put that together. Okay, so simplifying, I get X equals negative 15 plus or minus the square root of 225 minus negative 128. Now in this case, we have minus and negative. That means we'll be adding over negative 32. And that's why I want to make sure that I keep that separate. Okay, I want to keep that separate so that I understand what's happening there. Okay, so now I'm simplifying further. Negative 15 plus or minus the square root of 353 over negative 32. Now, the square root of 353 is not a nice number. Okay, you might be tempted to simplify radicals, but I'll help you out and say that if you were talking about how much time something's happening, typically we don't speak in terms of radicals. And so this would be a situation that we probably want a numeric answer, like a more numeric, more understandable answer. And so we're going to take the square root of 353, and you should get about 18.79. And so we get negative 15 plus or minus not the square root, we already did it, 18.79 over negative 32. So we split it into our two possibilities. Either it's negative 15 plus 18.79 over negative 32, or it's negative 15 minus 18.79 over negative 32. Okay, and as we do both of these, this gives us 3.79 over negative 32, which would simplify to negative 0.12. And this gives us negative 33.79 over negative 32, which gives us 1.06. Okay, so as we look at these two possibilities, we say, hey, this is when the ball hits the ground. We need to make sense of these answers. It says either the ball hits the ground 0.12 seconds, negative 0.12 seconds, which would be like before he throws the ball, or 1.06 seconds afterwards. Okay, so again, it seems like there's two possibilities, but there really is only one. Okay, just because there's two solutions doesn't mean that there's two answers. Okay, why did this quadratic only have one solution when they typically have two? One of the solutions was negative. Okay, it was a negative time. And so we know that wasn't a possibility. Negative, did I forget the I? Okay. When asked, what if I asked to find the maximum height of the ball? Could you use the quadratic formula? No, remember the quadratic formula helps us to solve. Finding the height isn't solving, it was more with graphing. Okay, and so we could find the height of the ball by finding the axis of symmetry, to find the x-coordinate of the vertex. And then that y value would be the height. Okay, since we're measuring by time and height. Okay, and that is solving quadratics using the quadratic formula. All right, see ya.